Hey guys, and welcome back to this class, Data Science, Deep Learning in Python, Part 2. At this point, we have a lot of hyperparameters to optimize. And this is only going to get worse as our neural networks get more and more complex. This is a topic called hyperparameter optimization, and I'm going to tell you all about it in this lecture. So let's take a look at all the hyperparameters we've learned about so far. There's learning rate, or if it's adaptive, the initial learning rate and the decay rate. We have momentum, we have regularization weight, we have the hidden layer size, and we have number of hidden layers. So what are some approaches to choosing these parameters? You've heard me talk about cross-validation a lot. This is when you split your data up into k parts and you do k iterations where you test on one part and train on the other k-1 parts. In code, it might look something like this. In the end, you average the scores and you pick the hyperparameter settings that gave you the highest score. It's important that you still keep a part of your data outside of this for testing. Previously, we only talked about training and test sets. But if you use that test set to choose your hyperparameters, then it ceases to be a true test set. So you need to keep a set of data outside of all of this and call that your test set. The training data you use when you calculate the cross-validation score is called your validation set. You can check out sklearn.crossvalidation.kfold so you don't have to split the data yourself. So what are some of the different approaches to hyperparameter optimization? There are two I'm going to talk about in this course: grid search and random search. Grid search is an exhaustive search, so you can choose a set of learning rates that you want to try, choose a set of momentums you want to try, and choose a set of regularizations you want to try. And then you try every combination of them. So for example, what I'm doing in this code. As you can imagine, this is very slow. But since each model is independent of the others, there is a great opportunity here for parallelization. Frameworks like Hadoop and Spark are ideal for this type of problem. Random search, instead of looking at every possibility, just moves in random directions until the scores improve. A basic algorithm would work like this. So we initialize theta, which is the set of parameters. We find the score at that theta, and then we loop through a maximum number of iterations. We choose our next theta to be a sample from the hypersphere around the current theta, get the score at this new theta, and if this score is better, we move our theta to this point. Note that there are still so many combinations and variations of the things that we've discussed so far, and this is still an active area of research. So what is the best combination to use? Nesterov momentum with RMS prop, or regular momentum with exponential decay? This is why deep learning is just as much an art as it is a science. Trying everything possible is infeasible, and you want to use your experience to guide you to the optimal solution.